I found this broken, abandoned 3D printer at the dump. It was missing parts and had clearly been exposed to the elements for years. And in this video, I'll show you how I repaired it and restored it to almost fully functioning condition using all the original parts. Let's get started. How's it going, guys? Angus here from Maker's Muse. Here on this channel, it's my aim to empower your creativity through technology, and 3D printers are an awesome way to do that. But 10 years ago, the only way to get a 3D printer was to either spend tens of thousands of dollars or buy something like this. Yeah. This is the Maker Farm Prusa i3 8-inch kit, released in 2013, as far as I can tell. It's a clone of the Prusa i3, which had only recently become the go-to design instead of the notoriously complex RepRap Mendel. Compared to that bucket of bolts, the laser cut frame could be put together over the course of a relaxed day or two, and in theory, you would have a working 3D printer. This machine, however, has definitely seen better days, and I found it sitting on a shelf in the Resource Recovery Center at the tip. The workers there obviously thought it was too good to go straight into landfill, so I picked it up for a sweet $20 dues and brought it home. It wasn't until I got it home, however, that I took a proper look at it and realized just how trashed this thing really was. It had been assembled with reasonable care originally, but obviously during its life, the previous owner attempted a variety of repairs and modifications before, as far as I can tell, leaving the whole thing out in the elements to rot. Absolutely everything is corroded on this. The threaded rods, the linear bearings, they look like they've been artificially rusted for one of those fake restoration videos. But I promise you, this is how it was. The linear rods are chromed, thankfully, but that didn't stop a few worn areas from starting to rust up. And on closer inspection, even some of the stepper motors are corroded. It takes a lot to corrode aluminium like this. I'm actually a little bit impressed. Inspecting the damage further, the laser cut plywood frame has taken an absolute beating. It's warped, floppy, and the top panel is literally smashed in half. At some stage, the previous owner replaced the front support with this chunk of wood, which is absolutely hilarious, and I am absolutely going to keep it this way. However, if I intend to restore this machine to a point where it can 3D print at all reliably, the frame is going to need a lot of attention. Finally, the electronics. Interestingly for the time, this kit actually has an LCD with SD card support, and it all runs off a RAMPS 1.5, which is an all-in-one shield for 3D printing that attaches to an Arduino Mega. The RAMPS 1.5 is an impressive bit of kit, even by today's standards, with support for up to 2 extruders using 5 removable stepper drivers. Although the dual Z motors are slave to the same one driver, so you can't do anything fancy like auto tramming or anything like that. It does, however, support a heated bed, which in this case is an early Prusa resistive trace bed that has the thermistor literally taped to the bottom with capped on tape. Whether any of this even works anymore, however, is a different matter entirely, because everything is coated in a thick layer of what looks like fine wood dust, and there's a ton of corrosion, and then there's this incredible texture left behind for what I can only assume is UV degradation. That isn't dust on the LCD, it's actually damage from the exposure to the elements for so many years. The hot end that it came with isn't stock, but it is familiar to me. This E3D V6 clone combo was, for the time, the cheapest hot end you could buy online. I think it cost under $10, complete with the power resistor and thermistor. It's set up for Bowden extrusion with this absolute garbage extruder. I wanted to try to use as many original parts as possible, so I decided to stick with it, which would end up being a mistake, as you'll find out later. It's worth noting that despite the extruded parts being discolored from age, it's never been used. The previous owner never managed to get this running, and it's never even had filament extruded through it. So it's got this weird new old stock vibe to it, which I've never really seen on a 3D printing part. But hey, it's not 2013 anymore, and you don't have to deal with dodgy 3D printers like this if you don't want to. Instead, you can take advantage of Micro Center's incredible tech deals running all the way through November. Black Friday starts now at Micro Center, with amazing deals in store from CPU and motherboard combos to desktops and laptops and a whole range of accessories. Of course, they still have all of your 3D printing goodies that you could ever want, from filament to parts, and this deal in particular, which caught my eye, for a Creality Ender 3 S1. The S1 is like an Ender 3 on steroids, with a 32-bit control board, direct drive extruder, and auto bed leveling, all for over $100 off. Very nice. Micro Center has been a long-term sponsor on this channel, and you guys have left countless comments on my videos of how good your experience has been with them, so now is an excellent time to head to your local Micro Center to stock up on parts and tech for the holiday season. You find links in the video description below. Now back to this, which certainly isn't an Ender 3 S1. We have a completely ruined frame that would have been sketchy from the start. We have every motion component rusted to oblivion, and all the electronics are covered in dust and corrosion, and I don't even know if they still work. Yeah, I'm starting to question my sanity in proceeding with this project, but by this stage I'd already posted an overview to the Makers Muse community and everyone wanted to see it working, so I'm kind of committed now. The first stage is stripping the frame down for a good clean and damage assessment, and first impressions aren't good. However, despite how bad the surface of the linear bearings look, they actually still seem to slide okay. The grease and rubber seals probably saved them, which is awesome because it means I can reuse them. Similarly, the belts are actually okay and they haven't noticeably degraded, so I can use them too. The Z-axis uses two M6 linear rods, which are also in pretty bad shape. This kit was made before Acme rods, you know, the kind with the coarse square threads, were easily available, but by using M6 screws, which have a 1mm pitch, Maker Farm was able to make a fairly accurate Z-axis movement, albeit requiring a very high step per millimeter value from the motors. To remove the gantry assembly, you need to remove the top plywood piece, which again looks like it's been violently snapped in half, but we'll fix that later. These linear rods run through nuts glued into the plywood on each side of the gantry, so I carefully loosened the spring couplers and lifted the whole mechanism free before giving each threaded rod a generous wipe down with WD-40 and running them back and forth using a cordless drill to free up the threads. They're a little floppy, but should still work, and miraculously don't seem to be bent out of shape, somehow. Now it's time to turn our attention to the frame, and it's rough. Again, this kit is almost 10 years old, and at the time, the only reasonable manufacturing process that these garage startups had access to was CO2 laser cutting, which meant designs using flat plates made of plywood or acrylic sheet were the way to go. Acrylic cuts clean and looks good, but it's actually really brittle. It has a tendency of cracking, especially when it's fastened together with T-slots like this machine is here. Plywood, on the other hand, is cheap and more resilient, but softer and less dimensionally stable, especially after a long period of time, like with this machine, as you can clearly see. The frame is bent like a banana, including the print bed, so those threaded rods are going to have to come out. I'm happy that I can reuse the majority of the original motion components, but the M8 rods used to hold the frame together are a totally different story. They're completely destroyed by rust, which is confusing because even the cheapest threaded rods I come across are at least zinc plated. So yeah, they must have been the cheapest of the cheap to rust this badly. And I did try to clean them up using a cordless drill and a die set, but I accidentally mashed the threads on one of them, and I did try to salvage it, but yeah, they're so soft I was just making a mess. Thankfully, I have a literal box of threaded rods from previous printers, so I just replaced them with a matching set. And if you've ever assembled an i3 kit like this before, you'll know just how tedious assembly of this step is, even when the threads are good, let alone mangled. So yeah, I just couldn't use the originals. Now onto the warped frame. The plywood now has this natural curve to it, which needs to be corrected. So to straighten it out, I used some of this low-cost aluminium U-channel screwed into place. It's crazy how much extra rigidity this adds, and it just goes to show how floppy these early i3 frames really were. I could go crazy adding that U-section everywhere there's space, but for now I just really want to get it printing, just vaguely reliably. Next up is the print bed, which is similarly bowed. I decided to just replace it entirely using some aluminium sheet from the scrapyard and bandsawing it out. And instead of holding the linear bearings in place with these horrible laser cut clamps, I just threw this linear bearing holder together in CAD and printed it out. I understand there's a bit of a chicken or egg problem here. You can't print parts for a printer that doesn't print yet, but there's no way I was going to reuse that horrible print bed, so I just used my Longer LK5 Pro to print those parts, so hopefully I can get this going. From what I can find online, the original Maker Farm kit came equipped with a Wade's extruder, or similar, which is a chunky geared extruder mated to a hexagon or maybe a J-head hot end. But that's not what this machine had when I picked it up. Instead, it had this, a very, very cheap E3D V6 clone and extruder setup using a Bowden tube, and it's clearly never been used. Again, it just was with the printer. So I went on making this work with a simple aluminium plate which attaches to the X-axis with holders for the linear bearings. that clamp it in place. In hindsight, I attached the hot end way too low, so I lose a lot of Z height, but that's a very simple change in future if I decide to use this hot end, which I probably won't. Next up, however, was the moment of truth. Did this poor abandoned control board still work? Coated in rust and dust from exposure to the elements for so many years. It has every right to be dead, right? But by some miracle, it wasn't. So it's time for an extrusion test. I checked all connections, making sure the thermistor was reading a sane value, and started a extruder preheat. And then this happened. Yeah, I have no idea what actually happened, but the thermistor wires self-destructed in a puff of smoke, and the LCD failed to initialize. After countless hours repairing this thing, I had blown it up. Or at least, I thought I did. It turns out that the LCD contrast pot was a bit dirty, and after a bit of fiddling, I did get the display back. But how about that blown thermistor? This printer comes from an era where the correct assembly process was to literally jam a glass bead thermistor into a hole in the heat block and then clamp the wires in place using a screw. Yeah, it's absolutely terrible and makes it very easy to compress the wires too much, leading to what I can only assume was a dead short on an I/O pin. Now, usually, when you short an I/O pin to the control board, it cooks the control board. But by some miracle, it seems to be okay. So I fished out an old worn-out heat block with a tube-style thermistor of the same value and screwed it into place. And bam, we have extrusion. Kind of? Yeah, from one problem to another, the extruder motor was screaming every time I attempted an extrude. At first I thought maybe it was a bad coil or the wiring was suspect, but it was only when I decided to check the extruder steps per millimeter setting that I realized just how messed up this printer really was. Yeah, you're reading that right. The E-steps are set at over 800 steps per millimeter. These steppers have a step angle of 1.8 degrees, which means one complete rotation is completed in 200 steps. This setting means that the motor was trying to rotate over 4 times per 1 millimeter of filament pushed into the hot end. This ridiculous high number, however, makes sense when you consider the original extruder had a reduction stage of around 5:1 from the motor to the extruder gear, but it's way too high for the new Bowden extruder. To fix this, you need to do an E-step calculation, but I couldn't even do that before bringing it down to a more sane value, and well, I'm all about doing things quick and dumb. After bringing it down to about 80 steps per millimeters, it was way more manageable, and although the E-step calculation is fairly simple, TH3D has an awesome wizard online that makes it even easier, and it spat out the number of 101 steps per millimeter of extrusion. The only issue is, I can't save it. The ancient firmware on this thing doesn't seem to support saving to EEPROM, and even when connected to my laptop through the serial port to try to view the settings directly, it just pulls up a blank screen. I did a preliminary search for the original firmware, but I didn't have any luck, so for now, the very hacky solution is to add the E-step change command at the start of every G-code file I print in the header. Horrible, but it works, and I wasn't interested in reflashing fresh firmware and figuring out everything else just to get this printing. And with that sorted, I think it's time to try some prints. My first attempts using the latest version of Prusa Slicer with an Ender 3 profile resulted in yeah, there's probably most likely some more recent commands that the ancient firmware can't understand, so instead I decided to slice with an old version of Cura baked into Repetier, and I printed a cube. And you know what? It doesn't look too bad. It's got an odd texture to it from what I can only assume is the stepper motor moving in full steps, I believe, and that's why the printer is so loud. And those black lines are from my repeated E-step calibration test, but hey, it's a cube and it's actually fairly dimensionally accurate. Next up, how about a knob for the LCD? I printed this Prusa LCD knob and it printed really nicely and it makes navigating through the menu much less tedious. And it's a milestone because it's the first part printed on this printer for itself. Because as far as I can tell, the original owner didn't print or fit any parts to it, which is very strange to me actually. They did, however, print things because there are sliced files on this SD card that was in the LCD module. I'm not going to be nosy and see what they were printing or even use this media But yeah guys, please always wipe or destroy any storage media for anything you dispose of, because you never know whose hands it might end up in. Now, because this is a 3D printing kit from the early days of 3D printing kits, I decided to try printing some of the most popular models of the time, including this Bender head, this owl facing left, the famous Yoda bust that was the torture test of its day, and my Maker coin. So let's see how these prints turned out. Well, as you can see, there's a lot of failures, so let's start with those. All of these coasters are from my attempts printing the Bender head, and there's a number of reasons they failed, getting better and better each time until I was finally able to print the final model. The first time it failed was due to this huge gap after the feeder gear into the Bowden tube. Because a Bowden extruder has a lot of force on that filament as it pushes forwards, it'll try to find any escape path possible to relieve that pressure. And in this case, with a gap that large, it just eventually pushed out. And it also didn't help the fact that the extruder motor was getting way too hot to touch because the extruder current was wound up way too high on the stepper driver. So I reduced that and tried again. And then we got this one, which did get a little bit higher, but then still failed. You can actually see it was actually having extrusion issues way earlier. That's because I wound the extruder current too low. So I did a few more tests, got a sweet Goldilocks zone, and then got this print. And these layer shifts are caused from something else entirely. The Y-axis belt was actually too loose, because tensioning belts on this machine is actually really tedious. And look, you don't need timing belts to be super tight, but they need to be tight enough that they don't skip teeth, which was starting to happen here, because this print bed with the glass on top and the aluminum sheet is actually, yeah, fairly heavy with a lot of inertia. Because I haven't tuned accelerations or jerk settings on this machine, it's just what it was from factory, I think it was just enough to jump those teeth now and then and cause these awful layer shifts. So I did end up tightening up, but you can see how the Y-axis stepper motor is actually starting to twist on its mount. It's just not a very good solution. And I got to this, so close, yet so far. Again, this is caused by that really annoying gap after the extruder gear into the PTFE tube, and it got all the way out to this point and then escaped through the side and stopped printing. So I was looking desperately in the garage for anything I could use to fix that. I tried a little bit of PTFE tube after the feeder gear, it didn't quite work, it got chewed up, so I desperately found an old nozzle which had an M6 thread so I could screw it behind the feeder gear, and I drilled it out to 2mm, which means there's almost no gap after the feeder gear for the filament to wander and escape. And then I got this print, which, yes, doesn't look amazing, but also keep in mind there is no cooling fan on this printer. Cooling fans just didn't come stock with most machines. It was always an upgrade part that people would print until way later down the track that they started to come default on 3D printers. And if you've printed anything, you'll know that a cooling fan makes a big difference for small details, especially in PLA. So for example, Bender's little antenna looks pretty poor here. And then there's pretty extreme overhangs here, which did fail. But again, I'm not sure how well that print on almost any printer, especially not one without a cooling fan. What I find interesting about this print is you can clearly see the motor's steps as it's been printing, because it's printing with such coarse stepping. It doesn't have fine micro stepping like modern stepper drivers would have on your 3D printer, which explains why it's so loud, but also why the print quality is so coarse. And of course, these extrusion lines are so inconsistent. You can clearly see extreme inconsistencies when the extrusion path has changed. So it's not too bad where it's mostly cylindrical, but as soon as it gets to the eyes, it starts to become quite poor indeed. And as it gets up to the top, there's actually under extrusion that's occurring, and then it gets to the antenna. So yeah, pretty poor quality print, but considering this machine was at the dump, it did complete it. And it actually did a decent job on my Maker coin as well. This is a small print, doesn't take very long, and the top surface again is pretty poor because there's no real cooling on this, but it's acceptable for a printer of this style. Back in the day, this is kind of the quality I'd get off machines like this. Even machines from the factory ready to go. This is kind of the detail I would get off Maker coins, especially the infill issues right at the top, where the tiny little solid infills are under extruded. That was really characteristic of some of these early machines I would deal with. But from here, unfortunately, it all went downhill. Here is the Yoda print, and you can see, again, the extrusion accuracy is fairly rubbish, but the real issue is when we start getting to the ears at the top of the head. It failed. This is not because the filament escaped through any external path, it's because it jammed. And this is because it started doing retractions as it got to this point. And this is where I discovered just how rubbish this clone hot end actually is. Because as soon as you start doing retractions, it fails and jams up the hot end. And I think I know why. You see, although the nozzle has a 0.4mm opening, it actually has a larger opening before that where the filament will start melting and softening as it gets towards that molten zone and is extruded out. And with this style of E3D hot end, it has a metal heat break that extends right down to that nozzle, and there is a hole that mates up with that nozzle. In this case, I think that hole is slightly oversized. And what that means is as the filament gets softened and pushed into that nozzle, as it retracts, it pulls back into that slightly oversized cavity. And because that cavity is slightly cooler, it will cool the filament down and make it a little less molten, and then it tries to push it forward again. But it's expanded from its original 1.75mm diameter into whatever that cavity is, and then it tries to force it into the nozzle, which it cannot, and then it jams up and the extruder gear will just chew the filament. And that was what was happening with this Yoda, and that's what happened with the Owl Bust as well. As soon as it started doing any kind of retractions, it just failed. And that's why it's in its current state right now, where I pulled it apart to find the problem. And honestly, short of replacing it with a completely new hot end, I'm not sure where to proceed from here. Okay, so was reviving this thing worth it? Well, yes and no. There's a reason you don't see 3D printers made from laser cut plywood anymore. It's just not good enough for a long-term, stable 3D printing structure. There's actually an incredible amount of force on every axis, and you can see just how these components have deformed over time. Just look at the Y-axis motor mount, like I mentioned. I had to jam some plastic behind it to stop it from skewing due to the belt tension. Combine those issues with a floppy frame design that changes bed level as soon as you move it in even the slightest amount, and the incredibly loud stepper motors. And poor quality extruder. And this really is a terrible 3D printer. But the challenge in itself to actually get this abandoned old 3D printer working with actually what was a minimal amount of new parts, that was absolutely worth doing, and I had a lot of fun doing it. Now I did get lucky, absolutely. The control board could have been fried, the axes could have been seized from additional rust, and the hot end could have been completely destroyed, and I would have had to spend a lot more time and money on replacement parts, but those are things that you can mostly assess from the start. Indeed, over on the Makers Muse community page, I did a post when I first got this printer where I connected the control board over serial, and I could give myself a sanity check to make sure the movement axes actually worked before dumping days upon days into restoring this thing. But I'm actually a little bit saddened by this clone E3D hot end. I can only imagine how frustrated the previous owner must have been trying to figure out why the extruder was making horrible noises, only perhaps to figure out the E-steps had to be changed, but alas, without a full firmware reflash, the new settings don't stick, and good luck finding the original firmware for a 10-year-old garage kit 3D printer. And even if they figured all that out, even if they did a custom flash and got everything configured, this thing can't handle retractions. It's a terrible hot end that just shouldn't exist. And I have vague memories from such horrors like this from years ago, where people would try printing out oilers and all these weird fixes to make awful hot ends actually work. But at the end of the day, it's just a badly made clone. I don't have any issues like this with the real deal. But I would love to know from you guys what you think should be next for this Maker Farm relic. The company no longer exists. They unfortunately closed up shop 2 years ago with their last printer, the Pegasus 10, looking a bit like a combination of this and the V-Roller aluminum extrusion designs that now dominate the budget 3D printer landscape. So do I persist in trying to make this old frame better with modern components, like strapping a E3D Hemera or equivalent hot end onto it? Or do I simply update the firmware and change the minimum parts required to make it print better? Maybe change some of the stepper drivers so it's a little bit quieter and more accurate? Do I throw a part cooling fan on it to increase print quality? Or do I throw the whole thing into the corner of shame and instead set aside a set of budget parts and make a printer from scratch using readily available parts and materials from the hardware store? Because I think I could make something more rigid than this with just bits from the hardware store. It's just really not very good. But what I would love to know from your thoughts in the comments below is what you'd like to see. And hey, if you do have a Maker Farm 8-inch Prusa i3 or a similar wooden 3D printed kit, let me know how it went for you. How was the long-term ownership experience of these machines? Because I distinctly remember having a humid summer day throw out the bed level on our first MakerBot 3D printer. Because again, it was a 3D printed kit made from plywood. Like the weather would change your print level. That's how the wood responds to that sort of condition, and it was really frustrating. But yeah, I'd love to hear your experiences in the comments below, and a big thanks to Micro Center for sponsoring this video on Makers Muse. Don't forget to check out their Black Friday sale happening right now until November 27th. Links below. Catch you later, guys. Bye.